You deposit $3,000 in an account that pays 6% annual interest, compounded quarterly. How long will it take for the balance to reach 3,500? So we can do 3,500 equals 3,000, and then 1 plus 0.06 over 4. You know, you don't get all 6% every time you compound interest. And then we're going to raise that to the 4 and the t, because we're talking about how long. How long will it take for the balance to reach 3,500? So now you could go to your calculator already. In Y1, we can just put 3,500 in. And then we could put 3,000, 1 plus 0.06 divided by 4. And then we can raise that to the 4x. Now the window is not from negative 10 to 10. It's not going to fit because we got this 3,500. So we can go to window, maybe go from 0 to 10. I don't know if 10 will work. We'll find out. But then we have to make this, how about not 3,500, but let's go a little higher, 4,000. And then we can make this, I don't know, something like 500 graph. So there's the 3,500. Let's see. Oh, and there's the function, fits in the window. And we can do intersection. So second, calculate. Oh, I did it a little too early. Oh, there we go. 5, enter, maybe get a little closer. Enter, and our answer is 2.588. 2.588, and that would be years. But I want to show you how to do this with logs instead of graphing, in case you prefer this. We have 3,500 divided by 3,000 equals 1 plus, I think the 0.06 divided by 4 is nice, actually. So 0.04 divided by 6. No, that's backwards. 0.06 divided by 4. 0.015 to the 4t. So we do the division. Let's find out what 3,500 divided by 3,000 is. And we get 1.16, and then it's repeating. 1.1666, keep on going, equals 1.015 to the 4t. Then you can take the natural log of both sides. And what that allows us to do is we can bring the 4t down. Natural log of 1.015. Now you can pick any log you want. But if given a choice, I usually just pick natural log. So we have this property that says if you take the natural log, you can bring the power down in front. So now the variable is not in the exponent anymore. And you can divide both sides by 4 times the natural log of 1.015. So the time, now it should say 2.588 years. So we have the natural log of 1.16 repeating, so let's put a bunch of 6's in, divided by 4 times natural log of 1.015. Whoops, I missed the 0. 0.15. Boing, boing. And there it is, at 2.588 years. So it's the same answer, it should be. I don't care which way you use, because later in the chapter, you're certainly not going to do intersection of 2 graphs. You're going to use these logs once we cover the logs. But I'm showing you a little early in case you can handle this, or in case you remember this from Algebra 2. The half-life of a certain radioactive substance is 9 hours. There are 20 grams present initially. When will there be 3.78 grams left? Well, we have initially 20. We're going to use this formula. We assume continuous growth or continuous decay. N equals N naught e to the kt. That's the formula you need to know. And if it's growth, k is positive. If it's decay, we expect k to be negative. Well, 10 is equal to 20 e to the k times 9. So that 20 becomes 10 in 9 hours. So we can fill in those values, and that leaves just k. So 10 divided by 20 is a half, e to the 9k. And now we can take the natural log of both sides. So we can bring the 9k down in front, and then the natural log of e is 1. Natural log of e says e to what is e? Well, e to the first is e. Well, now the answer is natural log of 1/2 divided by just 9, because the natural log of e is 1. We don't really have to divide by 1. Well, k is equal to negative 0.077. We expected it to be negative because this is half-life. It's decaying. We want to know when there will be 3.78. So 3.78 grams is equal to 20 grams e to the negative 0.077 t. We're trying to find the time. Well, you could set 3.78 into y1 and the other side into y2 and find the intersection, no problem. But you can also just do this more algebraically or numerically rather than graphing. So you got to do a little division. And then we take the natural log of both sides, 3.78 divided by 20 equals, that becomes negative 0.077t. Because the natural log of e is 1. So I can bring it down in front. Well, this is really this right here. So we can bring the power down in front. Natural log of e is 1. I don't have to worry about that piece. We end up with natural log of 3.78 divided by 20. Close the parentheses and then divide that by the answer we just got. So answer. And we end up with 21.632 hours. Then we can do almost the exact same thing with doubling. How long does it take $300 to double if invested at 9% annual interest compounded continuously? So we're looking at, we want to know when we will have 600. That's equal to 300 e to the 0.09 t. So we didn't have to find k this time. They gave us k. The rate of growth is 9%. That's 2 equals e to the 0.09 t. Now we can take the natural log of both sides, 0.09 t, and that'll be the natural log of e. So we can bring the power down in front. That's the power property of logs. Now, right at this spot right here, if you don't like this natural log stuff, because I really haven't talked about it yet, you can set y1 equal to 2, y2 equal to that little function, find the intersection point, no problem. You can find the answer that way. We have the natural log of 2 divided by 0.09. Again, natural log of e is 1, so I don't have to worry about that piece. So we get 7.7 years, 7.702 years. Questions on any of this? I wanted to show graphing E and show it without using a calculator, because I got that question when we were talking about these graphs. Well, E is equal to 2.718. So you have to have that memorized. You got to know that E is somewhere, it's just under 3. Like pi is 3.14. I'm sure you have that memorized. You have to have this one memorized as well. So knowing that, we can graph the parent function, y equals e to the x. Well, if I plug 0 in, we get 1, so 0, 1. If I plug 1 in for x, we get about 2.718, so it's about 2.7. So just shy of 3. Now, because I know the general shape of an exponential function, I don't really need a whole lot more than this. I got it. Because then the shape of the graph looks something like this, and I do know that it goes up very quickly. Well, that's enough to know, or to be able to graph this right here, e to the x minus 2. That minus 2 is on the inside of the function. That means we're going to move 2 to the right. So just move those over 2 to the right and make a similar shape, and we'll call that good. The domain is negative infinity to infinity. The range is 0 to infinity, and we do have an asymptote at y equals 0. So maybe you want to throw in the asymptote. Now this next one, the minus 2 is on the outside of the function, so it's really e to the x and then a big minus 2. This is on the outside, which means now the graph goes down 2. So the blue is going to move down 1, down 2, and then this one moves down 1 and down 2 right there. Well, that moves that horizontal asymptote down 2, so it's at y equals negative 2. So this is kind of the shape that we're looking at. Domain is still negative infinity to infinity. The range now is negative 2 to infinity. And the asymptote is y equals negative 2. Questions on how you would graph E. Just have to remember 2.718. Jordan wrote an exponential equation to model the cost of gasoline. He must have been bored. He found the average cost per gallon of gasoline for 2 years and used these data for his model. So we have the year 1990, it was $1.19. 2011, it was $3.91. If the average cost of gasoline increased at an exponential rate, identify the rate of increase. Write an exponential equation to model this situation. So letter A, we'll set 1990 as year 0, and the cost was $1.19. So that means 2011 was year 21, and the cost was $3.91. And since the equation calls for an initial value, it's real handy to just make the first year the initial value. Thank you. There you go. You're welcome. Now when we do n equals n naught 1 plus r to the t, see I don't have the, it should be 1 plus r over n to the nt, but the n is 1. So that's a 1, and this is a 1, because we're not like compounding it quarterly or daily. We're just looking at the price over 1 year. So the exponential equation is not like a compound interest. So that's why you don't have to worry about the n's. Well, we have the price was $3.91. The initial price was $1.19. We have 1 plus r raised to the, and then the t is the 21 years. Now on this one, I'm not really prepared to go over how you would solve this with logs, so we will do on this one the y1 and the y2. 391, $1.19, 1 plus x raised to the 21. Now, if you have something raised to the 21st power, it is going to increase very quickly. So we go zoom 6, and we see that, you can't see it, but the graph is hugging the y-axis very closely, because to the 21st power, it's going to increase very rapidly. So let's go to window, and let's go from -1 to 1 maybe. We'll get very close to the y-axis. There's that line. Here comes the function, right there. We want intersection, number 5. Enter, enter, enter. And we get 0.0582. So R is 0.058282. Well, now we have, so the equation is n equals 1.19, 1 plus 0.058282 to the t. So now on letter B, use your model to predict the average cost of a gallon of gasoline in 2015 and 2017. So we have this entire equation. And we just have to plug in. Now, if we're starting at, if this 0 represents 1990, then this is the first one's to the 25th, and then the other one will be to the 27th. 27. So this is just old plug and chug. 1.19 times 1.058282 raised to the 25th. Enter. So $4.90. Now your calculator has an entry function. You go second enter, and that brings up what you just last entered. And you just have to arrow over, change this to a 7. So $5.49. Now letter D says, why might an exponential model not be an accurate representation of average gasoline prices? Why would exponential not be a great model for this? Gas goes up and down. It doesn't just go up constantly. It fluctuates. So in the real world, oh, I guess I skipped C. Gas prices fluctuate. Let's do letter C. Let's not skip it. So letter C, when will the average cost per gallon of gasoline exceed $7? So you have 7 equals 1.19, 1.058282 to the T. And this one wouldn't be a bad one to do with, use natural log with. So we divide by 1.19. Take the natural log of both sides, or any log you want. It could be base 10, it could be log, that's fine. Then you can bring that T out of the power. So to finish it up, we take the natural log of 7 divided by 1.19, and then divide that by natural log of 1.058282. And we get 31 years from 1990. So that's somewhere in the year 2012. No, 2022, right? Because there's 20 years left. So, 2021. I don't know where I got 12. Questions on that? You can use the intersection of graphs. You can use this natural log stuff, whatever you prefer.